Hello folks, and welcome to the SO Hacker Log. I am your script kiddie in security land, and this is my network that is being monitored by Security Onion. If you want to learn how to monitor a small network at home using Security Onion, then see the link down in the description. In this episode, I am going to hack into the Mercury vulnerable machine from Vulnhub so that we can see what that looks like in Security Onion. Okay, so let's go ahead and get started. Once again, we are looking at multiple hosts that are logged into this network. And in the lower right-hand corner here, I have a macOS host. And in the lower left-hand corner here, I have an Ubuntu host. And in the background, I have a Windows 11 host that is logged into the Security Onion console. And I'm doing a walkthrough of the Mercury vulnerable machine that is available on Vulnhub, but my main interest here is in seeing what kinds of alerts this generates in Security Onion. Now, in the course of recording the video, I struggled a lot with instability in the Kali Linux compiled for Apple Silicon, so I don't think I'm going to be using it again in the future. Now, as usual, I am going to set the update frequency in the Security Onion console to 1 minute so that we can see updates here as they happen. Now I am going to go over to the macOS host and I am going to open up a web browser. And from there, I am going to go to Vulnhub. From the Vulnhub website, I am going to select series here, and then I am going to type planets into the search field. From those results, I am going to select Planet Mercury here. And Planet Mercury is just a popular beginner's level vulnerable virtual machine that we can hack into. And as you can see, there are some download links here. And I have included a few different walkthroughs down in the description. I have already downloaded this, so I am not going to follow these links again here. So I'm just going to close this web browser and I am going to open the Finder here in macOS. From there, I am going to go to the Downloads folder. And as you can see, I have mercury.ova right here. I am going to right-click on that file and copy it. Then I am going to navigate to the public folder of the SSH user that I set up previously on this Mac. And I have a link in the description to that video. Now, as you can see, this Mercury virtual machine image is already in the public folder for SSH user. If it wasn't, what I would do is I would right-click in here in this folder and I would select Paste Item. And that would cause it to be copied to this public folder. Briefly going to the settings down here in this macOS, I want to show you the network settings here. The Wi-Fi is connected to a subnet that has access to the internet. The Ethernet is connected to the intentionally vulnerable test network, and the firewall is active. Now, for some reason, macOS is not smart enough to figure out which subnet has access to the internet if it is connected to two subnets, one of which has access to the internet and one of which does not. If you find yourself in that situation, you can actually right-click on the network interfaces here and you can change the priority. It will check the first one only, and then if that one doesn't have access to the internet, it'll just cop out. Okay, so moving along here now, I am going to go to the Ubuntu host, and there I am going to open up the file manager. And from here, I am going to SFTP into the Mac. And going back to the Windows 11 host here, now I have logged into the main router on this test network. And as you can see, the Mac Mini has an IP address of 192.168.8.210. Also note that the intentionally vulnerable subnet here doesn't have access to the internet. And I never have this test network connected to the internet while I also have intentionally vulnerable virtual machines running on it. So going back to the Ubuntu host here again, I am going to click up here in the address field of the file manager here, and I am going to type in SFTP:// SSH at 192.168.8.210 and press enter on the keyboard. It will then prompt me for the password for SSH user on the Mac, and once I type that in, we will be browsing the file system on the Mac here from Ubuntu. I'm going to navigate to the users directory, and from there I am going to navigate to the SSH users directory. Next, I am going to go to the public directory, and there is the Mercury virtual machine file. I'm going to right-click on that, and I am going to copy it. Then I am going to navigate to the Downloads folder here in Ubuntu, and I am going to right-click and paste that file here. And that will copy the file from the macOS host over here to the Ubuntu host. Once that file is done copying, I am just going to double click on it here, and that will start the import process into VirtualBox. I am going to accept the defaults here and just click on Finish down here at the bottom of this VirtualBox Manager window, and that will start the import process. Once that import process is complete, I am going to scroll down to the network interface just to make sure that it is in bridged mode, and then I'm going to fire up this machine. Now, moments after I fire up that machine, it produces an error and says that it can't find the network adapter. So I need to go back and look at those settings again. I am going to close this virtual machine, and then down here in the network adapter of the settings for this machine, I am going to click on Bridged Adapter here, and I'm going to change it to NAT just temporarily to get this network adapter setting to update, and then I'm going to change it back to bridged adapter. And as you can see, it has now identified the actual network adapter for this Ubuntu Linux that is running. Okay, so now I am going to start up this virtual machine again, and it will take a minute or so to start up here. Once we get the Mercury login prompt here, we are ready to go. Now I am going to go back to the macOS host, and I am going to fire up this Kali Linux virtual machine in the VirtualBox Manager here. Going back to the Security Onion console here for a moment, you can see that pretty much as soon as I fire this Kali Linux machine up, Security Onion sees that Kali Linux has joined the network here, so that's good. Going back to the Kali Linux virtual machine now, I am going to open up a terminal emulator here. The first thing that I want to do is enumerate this network. So I am going to run netdiscover. And as you can see, I need to run netdiscover as root. So I am going to type in the command sudo netdiscover. Once that process starts, it begins enumerating the hosts that are on this network. Going back to the Security Onion console once again, this doesn't generate any alerts. And that actually makes this fairly stealthy. Now, it didn't actually seem to me like it should be because this does generate a fair amount of traffic on the network. And I spent some time investigating here. I'm not going to show that in this video because that is not the point of this video. But just take note that in this example, this ARP scan is a pretty stealthy scan, and it isn't really all that quiet on the network here. 192.168.8.140 is the IP address of the Kali Linux virtual machine on this network. And as you can see, there is quite a bit of traffic from it in a pretty short amount of time. Almost all of it is directed to the router, and almost all of it is on port 53. So Security Onion is probably just tuned not to alert us about DNS requests. I may do a follow-up video here where I look into this a little more and see about creating some alerting rules for this particular example. Also, if any of you know off the top of your head how to detect an ARP scan like this, then do leave a comment, please. But I'm going to move on here now. Also, as an aside, this exclamation point that has shown up here next to the detections menu option over here on the left is because this Security Onion server has attempted to download new community rules, and this subnet is not connected to the internet, so it was not able to. Okay, getting back to Kali Linux here, you can see that it has given us a list of potential targets that are on this subnet. Now, we could scan every one of these potential targets for services that we might be able to exploit, but in this case, we actually know which one our target is. If we look at the clients table in the router that is on this network, we can see that the IP address for Mercury is 192.168.8.211. So we are just going to enumerate services on that device. Okay, so back at Kali Linux here again, I am going to type in the command nmap -lowercase s uppercase v 192.168.8.211. And that is just a very quick service enumeration scan that will scan 1,000 of the most commonly used ports. So this scan takes a little while to complete, but if we go back to the Security Onion console here, you can see that very shortly after this scan starts, Security Onion starts noticing this scan. About a minute and a half later, and this scan completes. If I scroll up here, we can see that there are 998 closed ports. There is an SSH port open on port 22, and there is a web port open on 8080. Going back to Security Onion one more time, you can see that it has provided us with a few more alerts here from that scan. Okay, back in Kali Linux again, I am going to open up a web browser and I am going to navigate to that open web port. And when I do that, I am just told that this page is currently under development, so that's not real useful. So I am just going to go back to the terminal emulator here, and I am going to do a quick dictionary search for files that may be getting served by that web server. I am going to clear the results of this scan here, and then I am going to type in dirb http://192.168.8.211:8080. And again, this is just going to use a default word list to scan that server for files that it might be serving. As you can see, when I execute that command, it starts scanning that server for file names that it might be serving. When that scan completes, you can see that it found one file for us called robots.txt. Now, if we go to the Security Onion console here, you can see that this scan actually generated quite a few more alerts. So again, I am going to go back to the web browser here, and I am going to navigate to that file on this web server. Okay, so once again, this is totally useless. This is just a file telling web crawlers not to index anything on this web server, so that tells us nothing. Going back to the terminal emulator here one more time, I am going to clear those results again, and I'm going to use a tool that does a deeper dive into what that server is willing to serve up for us. So now I am going to execute the command ferrexbuster-u and the HTTP address along with the port for that server. Once I execute that command, it begins trying to see what it can extract from this server. And as you can see, it begins listing responses that it gets from the server. And this scan does actually take a fair amount of time to complete, so I'm going to skip ahead to when it's done. When this scan has completed, what we can see is that there are a number of error responses that this server has responded to FerrexBuster with, and pretty much all of them are the same length. So I am going to select one of these errors, and I am going to open it in the web browser and see what it says. That gives us a debug page generated by Django here, and it has given us a list of files here. So we have a new file to look at called Mercury facts. So I am just going to open a new tab here and navigate to that page. That takes us to a web page here, and this web page has a couple of links. If I select load a fact, it takes me to a fact about Mercury, and this almost looks like some not very well formatted Python right here, which would make sense considering that this website is operating on top of a Django framework, as we've seen. I don't honestly know though, so I am just going to hit the back arrow here and go back to the Mercury facts page, and now I am going to look at the website to-do list here. Okay, so we apparently have no authentication methods running in this web framework. We have a users table somewhere here, and we have a MySQL database management system that is accepting direct commands. So that definitely gives us something to work with there. Briefly going back to the Security Onion console here, you can see that there is definitely a problem on this network. And if we were to drill down into any of these alerts here, we would see that they are all coming from the same IP address. So in this example, we can already see pretty clearly that we are being attacked and which device on the network is doing the attacking. Going back to Kali Linux now, I am now going to use SQLmap to take a closer look at this database. I am going to use the command sqlmap-u followed by the URL for that web server and the database that it is serving, followed by --dbs and --batch. When I execute that command, it will start a pretty extensive injection attack against that database. Now that attack actually takes a fair amount of time, and if we go back to the Security Onion console here, we can see that that is immediately starting to generate quite a number of alerts here. Okay, so I am just going to skip to when this attack is complete. And as you can see, MySQLmap has identified a couple of databases here for us, Information Schema and Mercury. Now, if we go back to the Security Onion console again, oh boy, do we ever have a problem on this network now. Wow, yes, okay. So I'm once again going to go back to the Kali Linux console here, and I am going to again use SQLmap, but I am going to change the command slightly. Now I'm going to do -D, Mercury, --dump -all --batch. And what this command is going to do is extract any tables that it finds in the Mercury Facts database and display those tables here on our console output. And when I execute that command, it gives me a couple of tables here. Now, as you can see, this appears to be a table of usernames and passwords right here. So we can actually try these usernames and passwords with the SSH instance that is also running on this server. This is a short enough list so that I could go through them all one by one and just try them against the SSH instance that is running on this server. But I am going to go ahead and use a brute force method here anyway. And that is in part because I want to see if any alerts are generated by that in Security Onion. Now, this console emulator is running out of my home directory right now, and if I type in the command ls and execute it, then I will get a list of the subdirectories that are in my home folder. I am going to go ahead and also open my home folder in the Thunar file manager here, just by double-clicking on the home folder here that is on the desktop of this Kali Linux machine. And here I am going to create a couple of new documents, one for the passwords in that list and one for the usernames in that list. I am going to right-click in this window right here, and from the context menu that appears, I am going to select Create Document, and then I am going to create an empty file here. I am going to name it users.txt, and then I am going to click on the Create button right here. Now I am going to right-click on that file, and I am going to open it in Mousepad. Then I am going to copy and paste all of those users from the user table into this file, each on a new line. Then I am going to save it and close this file. Then I am going to go back to the home folder here in Thunar, and I am going to right-click again, and I am going to create another empty file. This one I am going to name passwords.txt, and once that one is created, I am going to right-click on it and open it. Then I am going to cut and paste the passwords from this table into that file, each on its own line too. Okay, so once those files are both created and saved, I am going to go back to the terminal emulator here in Kali Linux. I'm going to execute the ls command again, and as you can see, the two new files are here. Once again, I am going to clear all of this output here. Then I am going to enter the command hydra 192.168.8.211 ssh dash uppercase L users.txt dash uppercase P passwords.txt dash lowercase f dash lowercase v. And this is just going to brute force the SSH service running on the Mercury vulnerable machine using the password file and the username file that I just created. The process will also stop as soon as it comes to a valid combination. As you can see, once I execute this command, it is complete almost immediately, and the webmaster login and password are valid credentials here. And going back to the Security Onion console here, I just want to see if this SSH attack is picked up here. And yeah, as you can see, it is. Going back to Kali Linux here again, I am just going to go ahead and log into the SSH server running on the Mercury vulnerable machine. So at the prompt in the terminal emulator here, I am going to type in the command ssh webmaster at 192.168.8.211. And when I execute that command, it will immediately ask me if I want to accept the server's public key, and the answer is yes, I do. It will ask me for the password, which is right here, and once I enter that password, we have shell access on the Mercury vulnerable machine here. I'm going to go ahead and just list what's in the home directory here for the webmaster. And as you can see, there is a userflag.txt file and there is a Mercury project directory here. Now, if I type in who am I and I execute that command, you can see that I am not root. I am going to use vi to look at the userflag.txt file here. And as you can see, there doesn't seem to be much of anything useful here in this file. So I'm just going to type in :q to quit vi, and then I am going to cd into the Mercury projects directory here. When I list the contents of this directory, you can see that there are a couple of files and a few subdirectories. I am just going to use vi to look at this notes.txt file here. Okay, so there appear to be user accounts listed in here. It says both are restricted, and it gives us webmaster and Linux master with what appear to be encrypted passwords. So I'm just going to see how hard it is to decrypt this Linux master password right here. So I am just going to copy this encrypted password for Linux master here, and then I am going to go SFTP into the Mac. I am going to navigate into SSH users public directory, and I am going to create a file that has this encrypted password in it. Once I have saved that, I am going to open up the SSH users public directory from macOS, and I am going to open up that file that I just created, and as you can see, there is the encrypted password right there. I'm going to right click on it and copy it, and then I am going to go to a web browser and I am going to navigate to the CyberChef web page. Okay, so once that page loads, I'm just going to right click and paste that encrypted password into the input field here. And as soon as I do that, this little wand appears above the output field, and CyberChef has immediately identified this encoding as base 64 and has decrypted it to Mercury mean diameter is 4880 kilometers. So I'm just going to go ahead and click this wand right here, and that gives us the password in the output field here. Mercury mean diameter is 4,880 kilometers, so that's actually a pretty easy password to remember. And now I can re-SSH into the Mercury vulnerable machine using the new credentials that I have. So back at a new Kali Linux terminal emulator here, I am going to go ahead and do just that. Once I am logged in as Linux master, I am going to list the contents of the home directory here, and there is nothing. If I execute the command who am I am still not root. So I am going to see if there are any commands that Linux master is allowed to run as root. And the command for that is sudo-l. And Linux master is allowed to set an environment variable and is allowed to run a script here. So I'm going to open up that script in vi and see what it is. Okay, so that is a script to print out the last 10 entries of the syslog file. And tail here is an executable that is being executed by this script in order to do that. So we can actually interrupt this script by telling the system to execute something different when it is told to execute tail. And whatever that is that we execute instead should be running with root privileges, since we can execute this script as root. So I am just going to quit Vi here, and back at the prompt here for Linux Master, I am going to issue a few commands. The first command that I'm going to issue will create a file called tail in Linux Master's home directory. And when this file is executed, it will execute something different than tail. So the command I'm going to enter is ln-s/bin/vi tail. And when I execute that command, if I list what's in Linux Master's home directory, you can see that there's a file called tail there. And what that file will do when it is executed is it will execute bin/vi. So what will happen is vi will get executed if I execute this tail file. And the reason I'm choosing vi here to be executed instead of tail is because you can actually execute commands from within vi. And I've been using vi for a long time, and I did not know that you could execute commands from within vi before I did this Mercury virtual machine. Now, if I type in the command ls-l, we can see that tail here is a symbolic link to the vi binary file. Okay, so the next thing that I'm going to do is set an environment variable, because Linux Master is allowed to set environment variables as root. So I'm going to set the path variable to the working directory here. And the path environment variable, for anybody who doesn't know this already, just tells your computer system where to look for an executable file when you tell it to execute something. So the command that I'm going to execute is export path equals $:path. And again, that's just setting the path environment variable to the working folder, which is the folder that I'm in right now. So to give a little more explanation here, the dot is just whichever folder you happen to be in. And if I go to a terminal emulator here on my target box and I type in ls, it will list the contents of whatever folder I happen to be in at the moment. And obviously the terms folder and directory are interchangeable in this context. If I issue the command ls-a, it will show also the hidden files and hidden directories that are in that current directory that I'm in. As you can see, there's a dot and a dot here. The dot refers to this directory, whichever directory you happen to be in. The dot refers to whichever directory is above the directory that you happen to be in. So if I now type in the command cd dot and then I type in ls, you can see that I'm still in the same directory. If I type in cd dot and I type in ls, you can see that I am in the directory that is above that subdirectory that I was just in. And target is the home directory for this target box that I have running. Now, if I type in cd target and go back to that target home directory and I type in ls, you can see that I am back in the subdirectory that I was in before. If I type in ls-a again, you can see that there's the dot and the dot again. So the dot is just whichever directory you happen to be in at the moment. And this command right here just tells Linux to look in whichever directory you happen to be in at the moment for executables before it looks anywhere else. Next, I am going to issue the command sudo preserve-environment equals path, because I am allowed to set environment variables as root here. Then /usr/bin /check_syslog.sh, which is the script that I'm allowed to run as root. Now I am running vi as root here, and from within vi I can get a root shell. Now from within vi I am going to type :/bin /sh, and this should give me a root prompt here. Now, when I hit enter, I am dropped to a shell, and it does appear to be a root shell. So let's go ahead and see who I am here, and I am root. If I ls here, I can see that tail is here, so I'm in the same directory that I was in before. I'm going to change to the root directory, and if I list what's there, then you can see the root flag there. So I'm going to go ahead and open the root flag just to finish this exercise. Okay, so there it is. We have completed the hack of this intentionally vulnerable machine. And there is more than one way to root this machine, but this is more or less the way that the creators of this machine intended for us to do it. So let's go back to Security Onion now, again, to investigate this SSH traffic just a little bit more. We wouldn't expect normal SSH traffic to be alerted, and most of what we did there would have just looked like normal SSH traffic on a network, but some of it definitely wouldn't have. So if we scroll down here on the alerts page in the Security Onion console, we can see that some of this traffic definitely did get alerted. So it has told us that there has been some suspicious SSH traffic. Now, if we look at the total alert count for traffic associated with SSH, we have 6 total alerts. So the SSH attack generated quite a bit fewer alerts than what was generated by some of the other attacks that I launched. But we can still investigate this a little further. If I drill down on any one of the alerts that is listed on this page, we can see that with every single one of them, the source of the attack is 192.168.8.140. So I am going to go to dashboards in the Security Onion console, and I am going to dig into SSH traffic associated with that machine a little more. If we scroll down the statistics here a little bit, we can see that quite a bit of traffic on this network was actually initiated by the attacking machine here. I am going to click on its IP address, and I am going to include that IP address in the search terms here for this page. When that search term updates, we can see that most of the traffic that came from the attacking IP address here was directed at our Mercury target IP address. If we look over here too, we can see that Security Onion recorded 91 events from this source IP that are directed at the SSH port here. Okay, so I am going to update this search again to include our target IP address in the search terms. When that search updates, we can see that the majority of SSH traffic that came from this source IP address was in fact directed at this destination IP address. So I am going to update the search terms one more time to include only traffic destined for port 22, which would be SSH traffic. Then I am going to scroll down to the individual events. These events from top to bottom are listed from newest to oldest, so we can see that there is quite a bit of traffic from the attacking machine to the target here. Now, when we get almost all the way to the bottom here, we can see a brute force attack here, followed by a bunch of traffic afterwards. So we have pretty good evidence here that a brute force attack against this SSH socket was successful, and someone gained SSH access to this machine. And even if we didn't know that, boy, do we ever have a problem on this network.